Okay. So what it says up at the top here is we got to state whether each word or phrase represents an amount that's increasing, decreasing, or constant. And then what would a graph look like if it was one of those three things? So A right here, this says that the graph stays the same. So would that be increasing, decreasing, or constant? Yep, that's constant. So you're going to fill in constant on this one. And what's a graph look like if it's constant? Yeah, go ahead.
Just kind of like stays at the same level.
Yeah, good. Yeah, the y values stay the same. So the x values change, but the y values would just stay the same. So the graph would just be flat like that or horizontal. And the next one says the graph rises. So would that be increasing, decreasing, or constant? Good. So that's increasing. And what's a graph look like if it's increasing? What's that? Yeah, it's going up. It's going uphill left to right. So that would look something like this. Okay? So as the x values get larger, so do the y values. So that graph would go uphill left to right. And if it drops, it's what?
Decreasing.
Yep. So decreasing. So if a quantity drops, it's decreasing, and what would the graph look like? Going down, yeah. So it'd be going downhill left to right. So that would look something like this. All right, and then if it's slowing down, it could be increasing slowing down, or it could be decreasing slowing down. It could be either. So let me write, let's see. So I'm going to write increasing or decreasing. It could be either. So increasing. It could be increasing or decreasing. But basically, it's flattening out. The graph is going to flatten out. So it's not going to, doesn't necessarily become constant where it's completely flat. But if it was increasing and slowing down, it would start going like that. And if it was decreasing, slowing down, it would go like that. That make sense? Because if you look at a graph, from here to here, say from here to here. So let's say on the x-axis you had time. Over that time interval that I just marked off, it hasn't increased as much, right? The y values have not increased that much over this interval right here. It was steeper here, so I guess that's a way to say it too. If it's slowing down, it's less steep because you don't get as big a change in the y values. All right, so then the next example, they give you a situation and you have to match it to the graph. You just circle which graph matches it. You guys got all that stuff so far? So example 1 here. It says leaves are falling from a tree. Well, I guess we should note first. On the y-axis here, you have the number of leaves. And then on the x-axis, you have time. And then it says each day the leaves are falling. Then one day there's a gust of wind that blows off a whole bunch of leaves. And then eventually the number of leaves is 0. So then which graph do you guys think matches? First one, second one, or third one? Yeah, the second one. Good. Yeah, it wouldn't be this one right here, right? This one shows the number of leaves increasing. So it's not that one. And then this one right here shows that the number of leaves is constant, like the number of leaves on the tree does not change. So, yeah, so this one is decreasing. Then you get the gust of wind, so it decreases at a faster rate. So it's steeper. And then it's decreasing again to the point where you get down here. When you're right here, how many leaves are there?
0.
Yeah, good, Ryan. Yeah, when you get to there, the number of leaves is 0. So this is definitely B, or the middle one, I should say. So it's that one. So you can just circle it. And then the next couple lines there, those are, we got to write down the definition of what continuous and discrete means. So if a graph is continuous, well, if it's continuous, it's connected. Okay? All the points are connected. But I'm going to kind of write it weird. I'm going to say that you can trace it without lifting your pencil. So you can trace the graph.
Mr. Zimmerman?
Yeah.
Please don't mark them late.
Yeah, I got you.
All over. We're mixing and matching today a little bit.
I got you.
We're good.
So, all right, so I should say you can, but you trace the graph without lifting your pencil. Which is kind of a really informal definition, but that's okay. So you're able to trace the graph without lifting your pencil. And then discrete. So if a graph is discrete, in this case, it's just separate points. They're not connected. They'll say they're separate or distinct points. So separate points, I'll put not connected. All right. So then we're going to kind of go the other way now. In that previous example, they gave us the graph and we had to match it to the situation. This time, or maybe I said that backwards. They gave us the situation, we had to match it to the graph. But this time they gave us the situation, we got to draw the graph. So let's do number 2 right here. Okay, so this one, let's see, a truck driver, let's say you enter a street, so you turn onto a street, then you drive at a constant speed, then you stop at a light, and then you continue. So what would the graph look like? So again, notice on this one, you got the speed on the y-axis, you got the time on the x-axis. So let's say you're stopped at the light and you're gonna turn onto the street. So right here, your speed is 0. You turn onto the street, so your speed is increasing. Well, then eventually you're going to reach the speed limit, right? So what's going to happen to your speed then? Yeah, it's going to flatten out. It's going to be constant. So then your speed is constant when you're driving the speed limit. And then it says you got to stop at a light, so what's going to happen to your speed? Yeah, it goes down. It's going to be decreasing. And then you're going to come all the way. I guess I could extend this a little bit here. You're going to come down here to where your speed is 0 because you stop at a light. So you stop at a red light. And then if you continue, what's going to happen to your speed? Yeah, it goes back up. It's going to increase. You're going to reach the speed limit, keep going, right? So that is definitely continuous. You want to note that right there. That's a continuous graph. Because what is it doing? It's increasing. Your speed is increasing. Then it's constant. Then it's decreasing. Then your speed is 0. Then your speed is increasing. Then it's constant again. So I can definitely trace that without lifting my pencil, all right? All right, so that's good for that one. And then the next one, I'll slide up a little bit. So the next one, we're almost done. I guess I can't slide out much more. All right, this one says bookstore sells between 5 and 8 books each day for 7 days. So again, note that on the y-axis you got the number of books sold, on the x-axis you got the number of days. So you got 7 days, right? So you do something like, maybe I'll extend this a little bit again. Oops, I didn't want that color. So you got 1 day, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days. So here we'll put 2, 4, 6. Okay. And then the number of books sold varies between 5 and 8. So you got 1, 2, 3, 4, 5, 6, 7, 8. So let's see, 1, 2, 3, 4. There's 5, 6, 7, 8. All right, it doesn't tell us exactly how many books were sold each day, but it'd be something like this. So on the first day, let's say they sell 5. So you on day 1 right here, your X value is 1, your Y value is 5. On the second day, let's say they sold 8 books. So that would be up here. And the third day, they sell 7 books. That's about right there. The fourth day, they sell 6 books. Somewhere in there. And then the fifth day, they sell, well, I got an extra dot there. On the fifth day, they sell 8 books again. On the 6th day, they sell 8 again. On the 7th day, they sell 5 again. So something like that. Do we connect the dots on this one? No. It said this is a discrete graph, right? So these are separate points. In other words, you can't buy half a book, right? Like you're not going to connect this right here like this. Because you can't buy or you can't sell 6.5 books, right? There wouldn't be a point there. So let me undo that. All right, so that's definitely a discrete graph. It's separate points. You guys good with that? So definitely don't connect the dots on that one. All right, and I think we got to flip this over. I think there's like 2 more to go. Was that the last of that page? Yeah. Oop. All right, so page 2. Up here at the top, they want you to notice that you could get more than one graph from the same situation. So this first graph here on the left, this is the distance from the ground on the y-axis, and this is time on the x-axis. And this is supposed to represent somebody sliding, a kid riding down a slide. So you can see when time is 0 right here, the distance from the ground is greatest. Well, that's when you're on the top of the slide, right? And then the distance from the ground is going to decrease. And then eventually down here, your distance from the ground is 0 because you're off the slide, right? You're at the bottom. Well, then at the same time, you could do another graph based on the situation. So this graph here, you have speed on the y-axis and time on the x-axis. So here you are at the top of the slide right here. Your speed is 0. And then your speed increases because maybe the slide is steep there. And then the slide kind of flattens out, so your speed decreases. And eventually you get down to here where your speed is 0 because you're at the bottom of the slide and you're stopped, right? But that's just showing you could have more than one graph for the same situation. Now these last two, we got to make up our own they give us the graph and we got to make up the situation. So we got to write a little story for each graph. So here's number 4. So notice on the y-axis you got water level, and then on the x-axis you got time. So what's happening to the water level here? Yeah, it's increasing. Then what's up with the water level here? Yeah, it's constant, it stays the same. So over time, the amount of water does not change. And then the water is, yep. And then eventually right here, the water level is 0 again, right? So I don't know, we got to make up a situation for this. So how about this first section of the graph here, this part? Let's say we're filling a water tank. So we're going to write, you fill a water tank. We'll try to keep this simple. So you fill a water tank. All right, that's the first section of the graph. Then here you do nothing, right? You just let the water sit. So then you let the water sit there. So then you let the water sit over time. And then this last section, I guess you pull the plug and drain the tank, right? Until you get to the point where there's no water left in the tank right here. The water level will be 0. So I'll just say, then you drain the tank. I think that's good enough. All right, so it says you fill the water tank, then you let the water sit over time, then you drain the tank. That's it. All right, last one. So the last one is this number, I don't know, I guess it's not number, it's number 4, the second one. So let's say this one, let's say you're driving in your car. Okay, so you're driving your car. So what are you doing right here? This is speed on the y-axis and time on the x-axis. So what's going on right here? What's that? It's decreasing. So what do you, like, pretend you're driving your car. What are you doing to make the speed increase? I mean, say that again, Cameron? Well, let's say you're just driving along you could, but I'm just saying, let's say you're driving along a straight road. What's going on? What are you doing in your car when you're driving right here? The speed is decreasing. How do you make your speed decrease? Yeah, you're hitting the brakes, right? So you're slowing down, so you're braking. All right, then what's happening here?
Constant speed.
Yeah, maybe you set your cruise control or something. Or you're at the speed limit, one or the other, but we'll say you hit your cruise control. And then what's going on here again? You're slowing down again, right? You're using your brakes. Until you get to here and you're what? Yeah, you're stopped because your speed is 0 down there, right? Okay, so we just got to write that out. And again, try to keep it simple. So, I don't know. So we'll put you are driving your car. You are driving slowing down because you're on your brake. So you're braking. Okay, so you're driving, slowing down. Then you set your cruise control. That's what it'll be then. And then you brake until you stop, right? All right, does that make sense? So you're driving, that's supposed to be a W right there. Slowing down. Okay, so you are driving, slowing down, then you set your cruise control, then you brake until you stop. You guys okay? All right, so this assignment's like really short. So that's the three kind of problems you got. So in the beginning, they give you one where they give you a situation, they give you some graphs. You have to match it to the correct graph.